Hello and welcome back to our next unit in our discussion on creating web applications using Go. So what I want to do in this unit, in this lesson, is to look at uh, setting up an HTTPS server. Now currently we are serving, we are getting our requests and our responses using HTTP, all right? And as you know, for us to have encrypted our data, our responses, and our requests to be encrypted, we need to use HTTPS. So I want to briefly look at how we would do that so that our data is encrypted. So whoever is listening in between the client and the server, it won't really matter. Okay. All right. So we want to look at secure transfer. All right. And of course, by having using HTTPS, we do mitigate some of the DOS attacks. Okay, denial of service attacks. Now again, I will be using some of these terms loosely because I assume that you have heard them before. They have been discussed in your networking courses. So I'll just use the terms loosely. I will put some links up that elaborates on these topics if they were not covered or you forgot them. Okay, so the steps are rather straightforward. By the way, we'll be using TLS, right? Transport Layer Security, which is what we use for HTTPS. Okay, so let's go about setting up our web app to serve our requests or our responses and get our requests over HTTPS. So the first thing we need to do, we're going to make a directory, and let's call that directory TLS. Okay. Okay. And then let's go into that directory. Okay. Oops. Control L. Okay. So we are in the TLS directory. So now what we want to do, we want to, and the way how HTTPS works, we have to use certificates. Okay, we have to use certificates from some central authority that vouches for our server. Okay, that says yes, we know the server, it's secure, you can trust it, so on and so forth. Now, since this is practice, we won't get one of those signatures or third-party signed certificates. Okay, so what we'll do, we'll sign our own certificates. Now, if you're setting up a production server, of course, you would have to get your certificates from somewhere like Let's Encrypt. Okay, but since we are learning, we will sign our own certificates. Okay, but I want you to remember the idea of why we're doing it. Okay, so to create our certificates, we need to use the generate certificates tool that comes with Go. Let's see if we can find it. It's supposed to be in the source, wherever the source is, which, let's see, local, where's, let's go. Certificates, SRC, yeah, SRC. So we need to go into SRC, and we need to look at crypto. Okay, that's crypto. Okay, /crypto. Let me clear the screen. All right, so we're in crypto, and there should be a TLS directory here. Okay, so let me go into that directory. And then there's a program called generate underscore cert. Generate underscore cert. This one here. Okay. If we run this tool, it will generate the certificates for us. Okay, so let's just run this tool. All right, so I'm gonna say go run /USR/local/go da. All right, and the name of the tool. All right, so generate tab. Good. Now, after I have the tool, I have to specify what kind of encryption. And so again, we should know what encryption means. We're going to use RSA, and we're going to use RSA bits. Okay, and we're going to say it's 2048-bit encryption. And we're going to be doing it, of course, for the local host. Okay, since it's self-signed. It's self-signed. Okay, so this is the command, and what should happen is that it should generate the certificates for us. Okay, great. And notice it has a PEM extension, which simply means privacy enhanced mail. Okay, that's sort of the format that these certificates are created in. All right, so the cert.pem is your public key, and the key.pem is your private key. Again, I'm using those two terms loosely because I assume you already know what public-private key means. Okay, great. So if I do ls, okay, inside TLS we have our two certificates. Now let's just do cut to see what these look like. Again, the cert.pem is your private, is your public key. So that's what is sent by your client, okay, to the server that is communicating with. Okay, all right, it's public. Anybody can see that. Okay, so it's just it's encrypted. Okay, now your private key is the one that nobody should ever know about. Okay, but I'm just gonna show it here so that you can see it. Okay, but it should always be secure. Nobody should see your private key, because if they see a private key, then they can basically do everything on your computer. Okay, so like when the FBI or whichever agency wants to intercept or snoop in your, they get a search warrant to track your network, your activities on the web, then it means that they literally will get your private key. And if they get your private key, then they can see and do whatever they want. Okay, so the private key should always be private. Okay, so we have our keys. So now the next step is just a matter of setting up our server. Okay, and it is rather straightforward. All right, let's come here and notice we're using serve.listen and serve. And so what we want to actually do instead is to not use listen and serve, but to use listen and serve TLS. And it expects two things, the cert file and the key file. We have those. We just made them. So that /TLS /cert pem. That's the first one. And the second one is /tls /key .pem. Okay. Now, that's it. So there's one thing I need to do though, since we are using cookies, right? Session cookies. We now need to say that we will be using encrypted session cookies. Okay, encrypted session cookies. And so all I have to do is to turn on that field. Okay, session dot secure. Okay, and we will simply say, it's telling us, right? It says secure sets the secure attribute on a session cookie. The default is false. All right, it's recommended that you set this to true and serve all requests over HTTPS in production environments. Okay, so we'll set it to true because we will want encrypted cookies. All right. Okay. All right. Okay. I see my mistake here. It's not a function. It's actually it's a field. So obviously I can't call it. It's a field. It's a field. I can't call it. Okay. So secure that sessions that secure equals true. So now our cookies will be encrypted. Okay, that was very easy. Okay, all right, let's move on. Let's give this thing a try. So let's start up. Go, oops, go run ./cmd web. Okay, so our server is up. Good. Now let's do http :/localhost 4000. Oops, am I missing anything? Okay. Oh, okay. That shouldn't be there. All right. Localhost 4000. Okay. So it's saying client sent an HTTP request to an HTTPS server. So that's an error, right? So obviously, if you're going to call a HTTPS server, a website, their web app that uses HTTPS, then it will not accept HTTP requests. So what we need to do is to say HTTPS : /localhost 4000. Okay. Now, the first message you will see, and the reason why this message comes up is because we are self-signing our certificates. So the web browser is telling you, I don't have this certificate, this person in my memory. Because what happens, every web browser comes with a bunch of trusted certificate authorities, certificates from authorities, from centralized bodies. And so it is saying, I don't, this one is, I don't have this in my record. And so we have to actually go ahead and set it up. So we're going to say advanced. We're going to say, it's telling me, right, the certificate is not trusted because it is self-signed. We know that, right? We know that. Because remember, the web browser comes with only trusted and third-party signed certificates. So if you type up facebook.com or google.com, it knows that that certificate, right? When the server responds, it knows that you can trust it. Okay, so the browsers come with all of that. Accept and continue. And so it takes us, I know this little arrow, little padlock, right? It's saying this is basically saying it's not, you still have a problem. That's what the little thing there means. Okay. All right. So that is easy enough. What does the home page look like? See, Control I. Okay. So if I say Control I, right? Control I, Control I, we see that there's a security tab now present. And this security tab actually has, it tells you about the certificate, like the encryption, TLS, AES, the cipher suite, what version of TLS, and so on, right? And notice this is a certificate, right? The certificate, right? And notice what it's saying about the certificate, right? Because every certificate must be signed or whatever, owned by somebody, right? Or verified by somebody. And it says it's verified by Acme Corporation, right? And of course, if you watch cartoons, you know what Acme means, right? It's factitious, okay? And factitious, yeah, it's factitious, right? So Factatious. Factitious is like fake. Factitious, right? Artificially created or developed, right? So don't think the word fact means it's true, right? All right, so Acme, of course, is just a made-up name, right? You see it a lot on cartoons. Anyway, so that's the reason why they put Acme as the owner, since it's a self-signed certificate. So it's verified by no one. All right. So with that out of the way, I want us to look at how our header looks using HTTPS. So see, Control Shift E. Would that be right? Control Shift E. Yeah, Control Shift E brings up the developer tools. And so if let's say if I navigate to create quote, oops, let's go back, / create / quote. Okay, so oh, I gotta get my URL backwards. Quote / create. Okay, so you'll notice that we have, like, if you look at network, right? If I click on this particular packet, right, you can see the header. Notice HTTP2. So one thing with using HTTPS is that if whoever you're contacting, the server, the server is using HTTP, the connection is using HTTP2, then it will automatically be upgraded to HTTP2. And that only happens when you're using HTTPS. Okay? All right, so again, that's just a bit about the advantages of using HTTPS. Number one, security. Number two, you use version 2 of HTTP of HTTP of the HTTP protocol. All right. Again, I'm just using these terms loosely because, again, I assume you've done networking and you have heard these terms, you've discussed these terms. All right. Let's one thing I want to do, since we're talking about keys, let me stop this, Control C. You don't want your keys. What I do, I usually commit the changes I'm making to Git. And so if you're going to use Git, you don't want to commit your keys in the Git repository, because if you do that, then it will always, Git will remember. All right. So even if you delete the folder, then whoever has the files, whoever you give this quote box directory to, they could always check out a previous version, and right away they'll get back the folder. All right. So you never want to commit your keys, and so to do that, in Git you simply create a .git ignore file. Okay. So let's just do it in one step. I want the TLS directory to be ignored, and I will at the same time create the git ignore file. This file has to be named git ignore. Okay, has to be named this way. Okay, okay. So if I say cut that git ignore, you'll see that TLS. So what Git will do before it saves or commits whatever you want, it will make sure that it does not track this directory. All right, so it will not track this directory. Okay, good. So always remember, whatever you don't want to be tracked, meaning whatever is private and is security related, you always want to put that in the git ignore file. Right? So your passwords and usernames, you put that in git ignore. You don't want that to be tracked. You don't want Git to remember it. Okay. Okay. All right. So that's a little bit of DevOps that you just learned there about git ignore. Okay. So that's easy enough. Let's talk a bit about encryption and the different approaches. So, for example, there are different encryption schemes where the private key changes, right, for every connection. Every connection. So if today you connect to Facebook, the private key is something. The next time you the next time you log in, or next time you open your browser and you go back to Facebook, or let me put it this way. Each time you create a connection, meaning you open your browser, a new key is created for you, which is good, right? So for example, if the FBI got a warrant, or if the police department got a warrant and they got your private key and they said, yes, we got the private key, but then it's using one of these encryption schemes, which means it changes every connection, then it means that the police department will have to get another warrant to tap or to get your key. All right. And so that's one of the benefits of these advanced schemes, whereby each connection creates a new key. Okay. Anyway, let's see how that would look like. Okay. So there are different schemes, and I'm going to talk about one of them. And to use that scheme, in fact, I'll just use it and let Visual Studio Code put in the library. Okay, so I need to configure TLS. Okay, I need to configure TLS. Okay, so I'll just put it right here. Okay, so again, everything you can configure. Okay, so TLS, I'm going to call this config. Okay, and then I will just set the properties, the fields on the TLS config directory. Okay, all right. So I could set, and let me just set this first one, the curve preferences. Okay, and I will use these two. Okay, this is very common one, curve ID. Okay, and we're gonna use TLS dot x 2219.519, and we will use TLS dot curve P256. Okay. Now, what does this curve mean? It's just elliptic curve cryptography. It's one of those techniques that I use a lot in blockchain. But basically, it's what I was talking about, where it allows you to get a new key, a new encryption key, each time you open a new connection. And so it doesn't really persist for too long. Okay. Again, I'm using these terms loosely because I assume you have some knowledge. Okay, and I'm not going to spend uh, a lot of time dealing with those topics, since they're for other courses, right? They're for other courses. All right, and so all I need to do is to add this to my server. Okay, I'm just going to say TLS config is going to be TLS config. All right, easy as that. All right, good. So that's one way of using elliptic curve Diffie-Hellman encryption scheme. Okay, so elliptic curve. This is an example of ECDHE. Okay, that's the scheme. All right, and it simply means elliptic curve. Okay, Diffie-Hellman. Okay, all right. Now, don't feel overwhelmed if you're feeling a bit confused, like what does that name mean, and whatever. No, the whole point is just to show you how to set up an HTTPS server. The other things you can find them in documentation, and the reality is you get used to this after working with HTTPS servers. You just get used to it. Okay, so don't feel overwhelmed that you might not know exactly every piece of the code that I'm writing. Okay, all right. So let me just add two more things to this, and then we will be all set. All right, I'm just gonna say that I'm gonna prefer cipher suites to be true. Again, cipher suites. All right, and then I'm gonna set a few more settings. Okay, and these are just for the server. Idle, timeout. Right? How long should the server wait when there's an idle connection, right? When should it close it? Uh, let's say a minute. So if you have a browser open and you're not really using it, um, then whatever connection that browser has will be closed, right? Will be closed. That's what it means. Now, when it comes to read timeout, it simply means that how long should the server take when it comes to reading a request, okay, when it's getting a request. You know what happens a lot of time, there's this attack called Sloris, if I recall, Sloris, and it it's a denial of service attack. And what it does, it only sends a piece of a request, right? Piece of a request at a time, piece of a request, piece of a request. And so the server is so busy responding, reading and responding to that piece of request, um, that it's a denial of service attack, right? It's denying other clients from connecting to the server because the server is busy working with trying to respond. And so we want to prevent that from happening, and so we have to say how long the server should be reading request. Okay, so we're gonna say time 5 seconds. Okay, and then of course when it comes to writing responses, okay, all right, close the connection after 10 seconds. All right, again, these are just things that are used to mitigate denial of service attacks. Again, denial of service attacks, right? Distributed denial of service attacks. All of these things are things that you would have discussed in your networking course or some other course. All right. Okay, and that is it when it comes to configuring your server. So in reality, the only thing you really need to know, although I will expect you to do all of this, is that you need to, by the way, notice that this package was installed, right? Crypto TLS. Okay, that was needed when I did the preference server side for suites along with the other curve preferences, right? Okay. Now, as I was mentioning, the only thing you really need to understand is that you've got to switch the server from just listen and serve to listen and serve TLS. You've got to make sure you have the certificates listed. And then the key thing is also to remember that your session cookies will also need to be encrypted. And that's what we do here. All right. Apart from that, the rest is just configuration, fine tuning the server to use, for example, elliptic curve cryptography, um, and ensuring that your server is sort of resilient to certain denial of service attacks. Okay, so it's just basic configuration. Again, these configurations, they come with practice, they come with reading up the documentation, they come with what are you expecting from your server, what are the requirements of your server. All right, so again, I say these are sort of DevOps type of things where you're fine-tuning your server. All right. Okay, so that's it when it comes to security and using or creating an HTTPS server. Let's just give this another run just to make sure everything works, and that will be it. Nope. Okay, let me run it. Go run that /cmd /web. Okay, so if I come back here, we should still see it working, right? Still works. Still works. Okay, so that's it. We're finished with setting up an HTTPS server. Going forward, we're going to use this HTTPS server, all right? Because the only remaining lesson we have is how do we authenticate users, right? So meaning, how do we make someone log in? How do we make someone log out? And how do we let someone sign up, all right? Sign up. So that's what we'll be looking at, and that will be the end of our discussion when it comes to web applications. All right, so I'll see you in that next lesson.